In September, Cyclone Boris caused severe flooding in Galatsi County. 2 dams gave way and many roads remained closed. Statistics show us how the frequency and intensity of extreme phenomena like this have increased in recent years all over the world. And part of the blame lies with global warming. At first glance, it seems paradoxical. Global warming is responsible for increasing the Earth's average temperature by 1.5 degrees since the industrial era. What does 1 degree mean? It seems like a small amount. And why would this lead to extreme weather phenomena such as floods, more devastating storms, or on the contrary, droughts and record high temperatures? In this video, I want to clarify the relationship between global warming and extreme weather phenomena, starting from the known laws of physics. I hope you'll watch this video until the end to see why physics doesn't mess around and why global warming also leads to extreme weather phenomena. There's more. Vanda! In a series of 3 episodes, I explained in detail what global warming is and compared it to a blanket effect. As we burn fossil fuels, we put more and more carbon dioxide into the atmosphere. It works like a blanket, preventing Earth's infrared radiation from escaping into space and thus further warming the planet. Since the beginning of the industrial era, the concentration of carbon dioxide in the atmosphere has nearly doubled, and the Earth's average temperature has increased by more than 1 degree Celsius. Some of the consequences are extreme weather events, as atmospheric physics tells us. Let's take them one by one. At the root of many extreme phenomena, which are consequences of global warming, lies the increase in water vapor in the atmosphere. So, as we know from being in a sauna, the warmer the air is, the more water vapor it can hold. For every 1 degree increase in temperature, the atmosphere can hold about 7% more moisture. These additional water vapors not only amplify the greenhouse effect, since water vapor is a powerful greenhouse gas, but they also provide more fuel for heavier rain and heavier snowfall. Simply put, with more moisture in the atmosphere, storms will produce heavier precipitation, leading to floods. Extreme phenomena, a consequence of global warming, have another ingredient: high-altitude air currents. Thus, air currents form due to temperature differences between 2 areas, which in turn create differences in pressure. And the higher pressure air, which is cold, is pushed toward the lower pressure air, which is warm. If the temperature were the same everywhere, the pressure would also be the same, and the air would remain still. For high-altitude currents, the temperature difference above the Arctic near the North Pole, which is colder, and above the equator, which is warmer, is important. Global warming increases the temperature everywhere, but in practice, the North Pole is warming more than the equator. That means the temperature difference between the Arctic North Pole and the equator is decreasing. With a smaller temperature difference, the high-altitude air current, the jet stream, also weakens, causing it to take on more sinuous shapes and create stagnant weather patterns. Because cold and warm air no longer change so quickly, we will have atmospheric blocking. The consequence is that we will have less frequent changes over time. Heat waves, when they come, will last longer. Atmospheric blocking is a meteorological phenomenon in which a high or low pressure system remains almost stationary over a region for an extended period, usually several days or even weeks. Normally, pressure systems move in the atmosphere, influenced by jet streams, but in the case of atmospheric blocking, these systems become stuck and stop moving, which can have significant consequences for the weather. Global warming increases the Earth's average temperature. It's normal then to statistically expect more heat waves and longer dry periods, but there's more to it than that. As we've seen, because the Arctic region is warming faster than the equator, the temperature difference between them is decreasing. The cooling that comes from pressure systems moving under the influence of the jet stream is less effective. That's why heat waves and droughts here, when they occur, will last for longer periods of time. The effect is more pronounced in cities, also due to urban heat islands, because concrete and asphalt retain heat. In addition, higher temperatures lead to increased evaporation of water from lakes and soil. This can deplete the water source on land and dry out the soil, contributing to drought conditions. Additionally, higher temperatures also lead to higher rates of plant transpiration, which dries out vegetation even more, making the drought even more severe. The average temperature has increased by more than 1 degree in the industrial era due to global warming. It's no wonder that the number of wildfires has also increased, especially in areas like Australia, California, and the Mediterranean region. However, there is an important physical process to be aware of here. Thus, as we discussed in previous episodes, and as we know from the infrared thermometer, a body with a higher temperature emits more infrared radiation. The Stefan Boltzmann law describes the relationship. In this way, higher ground temperatures lead to greater heat radiation, which dries out vegetation, making it more flammable. There's another contributing factor to this. Warmer air holds more moisture, increasing evaporation rates from soils and vegetation. This leads to drier conditions, greater drought, which makes forests more susceptible to ignition. Higher temperatures can also intensify storms, increasing the number of lightning strikes, one of the main natural causes of wildfires. NASA data shows that prolonged droughts in the western United States have contributed to increased wildfire activity from the 1970s until now. Ocean temperatures have risen due to global warming, and the higher the temperature gets, the more heat energy it stores. You can see this in this graph. The ocean's heat energy has increased, reaching a value on the order of 10 to the power of 23 joules. However, this is an additional energy source for tropical storms, hurricanes, and typhoons. Thus, through evaporation, more moisture is added to the atmosphere, which releases heat when it condenses. Since the beginning of the industrial era, the average surface temperature of the ocean has increased by about 0.8 degrees Celsius due to global warming. What happens to water when it gets warmer? It expands. That means the oceans physically get bigger. Look, let's do a rough calculation with the new version of ChatGPT 01 preview, which was just released and is said to be very good at this kind of calculation. That's the problem. ChatGPT is calculating the ocean's water volume. Here, it's calculating the increase in volume due to the rise in temperature. Then it calculates the expected rise in sea level. It comes out to about 30 centimeters. How much has the water level actually risen? We can see in this graph, about 20 centimeters. Through a simple calculation, like the one done by ChatGPT, you remarkably get a similar value. In fact, the new version of ChatGPT overestimated sea level rise due to thermal expansion by a factor of 3. Why? Because only half of the observed 20 centimeter increase is due to the thermal expansion of water. The other half is due to the melting of land ice, glaciers, and ice sheets. Thus, the ice sheets in Greenland and Antarctica, land ice, note, not floating glaciers, along with mountain glaciers, are melting due to global warming. This introduces more water into the oceans, raising sea levels. Since 2002, Antarctica has lost nearly 2,500 billion tons of ice, contributing significantly to global sea level rise. Accurate satellite observations confirm a global average sea level rise of about 3 millimeters per year over the past decades. If fossil fuel consumption continues at current rates, sea levels are projected to rise by up to 1 meter by 2100 in high-emission scenarios. I can't help myself here. I'll give you an exercise. We have an ice cube floating in a glass of water. After it melts, what is the water level? Higher, lower, or the same? I'll wait for your answer and explanation in the comments. Gotcha. The amount of carbon dioxide in the atmosphere has increased. It's the cause of global warming. The amount of carbon dioxide absorbed by the oceans has also increased. As you can see in this reaction, the additional carbon dioxide interacts with water and increases the concentration of hydrogen ions in the water. However, the concentration of hydrogen ions in ocean water determines the water's pH, which will consequently decrease. This is confirmed by measurements, as you can see in this graph. The pH has decreased in the oceans by about 0.1 in the last 35 years. We say that the ocean water has become more acidic. We will talk in a future episode about the consequences this has for marine ecosystems. Permafrost is a layer of soil or rock that remains frozen for at least 2 consecutive years. It is found in polar regions and in high mountain areas. As expected, global warming leads to the melting of permafrost, releasing methane, a greenhouse gas that is 30 times more powerful than carbon dioxide. This is a side effect of global warming, but it's good to know because it will accelerate the process. Global warming is more than just a rise in average atmospheric temperature. Just as important is the increase in frequency and amplitude. On one extreme, we'll have more heat waves and droughts, and on the other, storms and floods. The purpose of this episode was to understand through physics how global warming leads to extreme phenomena. In the next episode of this series, we will detail the impact that extreme phenomena could have on human societies. Stay tuned, especially if you are young. You will see the changes with your own eyes, just as we, the older generations, are seeing them now with our own eyes. Until next time, please subscribe if you haven't done so yet by pressing this button right now. Thanks to our Patreon supporters and channel members. I'm Christian Prasura, Physics Explained. You're cool and I wish you the best. Goodbye.